once we're here and we've actually multiplied all that out, notice what you can simplify here. I can do the 8 minus the 8, which isn't that convenient, it cancels out. Who would have thought? All right. But then, you notice we got that h on the bottom?
No, that was funny.
That can cancel out on the top as well, because you notice we have an h in every single term on the top as well. And so the whole thing then ends up just being the limit as h is approaching 0 of 12 plus 6h plus h squared. Now, it is only at this point, only after we've canceled, that I now can plug in the 0. Because if I had plugged in that 0 at the start, of course I would have divided by 0. I can't do that. But at this point, I can actually do it. And so now if I plug in 0 for h, you notice the whole thing then equals 12.
I got that answer.
And so then that is our final answer. That is the limit we're approaching. All right, so we went through the whole process, and we actually canceled something out of both top and bottom. Once we've canceled out, that tells us that we may now be able to go ahead and plug in our value, the value that x is approaching. And so, let's actually try plugging that in here and see what we get out of it. So it's going to be, of course, 1 over 3 times 3, and just plug it into every place. X plus 3. All right, and so,
plus 3?
oh, yep, sorry. And so then we can go ahead and figure that out. So it's going to be 1 over 9 times 4, which is going to be 36. And so our final answer then, notice it's not D and E, it actually ends up approaching 1/36. All right, so this is the first example using our new method. The fourth method there is to go ahead and combine the fractions. So notice I got two fractions that are being subtracted. That's what I'm going to end up doing with this one. Now notice why I have to, though, make this your habit of always checking this first. It's the limit as t approaches 0. Notice if I plug 0 in, I'm dividing by 0, it's undefined. Same thing in this one as well, although it only has to happen in one of them for it to be undefined. But my goal is to go ahead and combine these two fractions. That means subtract them. Now, of course, in order to subtract fractions, we need a common denominator. Now, notice in this case, though, that that first fraction, it just has the t in it. And the other one is t squared plus t. I don't want to have to multiply this whole first fraction, though, by the whole t squared plus t, because I actually don't have to. First step, whenever you're doing one of these, in order to make your life a little bit easier, look to see if you can factor anything. Because in this case, notice I can factor the t out of that second denominator. And the beautiful part about doing that is that notice it has t as one of the factors, just like I already have t over here. So when I go to get the common denominator, I'm going to be multiplying top and bottom of this first fraction just by the t plus 1. And you notice as I write it out, I go ahead and just leave it in all the factored forms. Certainly in the denominator, doing so is going to make your life a lot easier. Because now I can go ahead and do the subtraction. And you'll notice that when I do that subtraction, the 1 minus the 1, that ends up going away. So all we're left with in our numerator is just the t. And that's why this method can work, because I'm sure you already see it there. We can do some reducing, right? I can cancel out a t out of both top and bottom. And when I do that, then what I'm really dealing with is the limit as t is approaching 0 of 1 over t plus 1. Now I canceled something. Whenever I've canceled something, that usually is an indicator that it's time now to go ahead and try plugging back in, trying the substitution again. So let's do that. Let's plug 0 in. 1 over 0 plus 1. Yeah, we're not dividing by 0, so this is actually going to give us our value. And so, just 1 over 1, which is 1. And so that's our final answer here. This limit is approaching 1.